Hello, everybody. I believe that you hear me. My name is Morten Dahlen. I'm director of dScience, Center for Computational and Data Science at the University of Oslo. We are working on creating projects across disciplines together with partners in academia around the world and also with partners in industry and public sector. In addition to that, we are having various types of events, and we have a series here at the Science Library, and thanks to the Science Library for using these premises. Unfortunately, right now, they are redoing the kitchen here, so today this area is a little bit narrow, but I think it works. We have a record many participants today, and I believe that's because of the very, very interesting topic that we are going to hear about. Today is also a big day for artificial intelligence, research, machine learning, and all around that in Norway. 1 hour ago, the Prime Minister and the Minister for Research and Higher Education came to the University of Oslo and announced that within the next 5 years, they are putting 1 extra billion Norwegian kroner into this research domain. And of course, it's important for us in dScience, it's important for our research groups within machine learning, artificial intelligence, and related topics. And one of these groups are the language technology group at the Department of Informatics here at the University of Oslo. And today, I'm happy to announce that we have one of our scientific staff here, Andrey Kutuzov, and he will talk about language models, artificial neural networks, and who they belong to. And I think this is a very hot topic. It's not only a hot topic in Norway, it's a hot topic all over the world. And it's fair to say, I remember very well, back about 20 years ago, the language technology people moved from the Faculty of Humanities to the Faculty of Mathematics and Natural Sciences at the Computer Science Department. We didn't really know how popular this field would be in the future. And it's fair to say, André, that you are more popular than ever because of what happened about a year ago with the ChatGPT. So, this is my intro today, and Andrew Kutuzov, the floor is yours, and please tell us who these models should belong to. Okay, thank you very much.
Yes, it works. It does? Yes, cool. Thanks, Martin. Yes, and hello everyone, and thanks for coming. It's great that we have so many people of all ages here, including babies. Right, so yeah, you have already introduced to some extent our group, but still, for those who are curious, I'm an associate professor at the Language Technology Group, which belongs to the machine learning section at the Department of Informatics here at the University of Oslo. So we have our study programs, both on bachelor and master levels, and yeah. For professors, 1 postdoc, 2 researchers, and several PhDs, some of whom are here today, which is great. And yes, we are doing natural language processing, also called natural language understanding, which is, in simple words, making sense of human language. Right. And I guess I will talk about language models, about large language models, and about some important things which I think should be discussed when we talk about these things. But 2 important disclaimers should be made before the talk. First, by necessity, I'm limited by time, so I will not cover many topics which you might think are important for language modeling. So this is just a selection of topics which I want to talk about today, right? And the second disclaimer is that the field, or well, the subfield of language modeling is exploding right now. So the pace of development, the speed of development is astonishing, which means that some of the things that I will be saying today will probably be outdated in a few months. So we in NLP learned not to make very bold claims. So please do not think that what I'm saying today is some God-given relation. It's just the state of things as they are right now. Everything might change in a few months or in a few years. But still, I think that some stuff will remain important. Okay, so language models. You all, of course, know about ChatGPT, already a not so recent language model by a company called OpenAI, where probably the word open is the only open thing about them. So the title is the only open thing about this company. You might think about it as essentially being Microsoft, because Microsoft is the largest stakeholder in OpenAI. But of course, ChatGPT is not the only available and powerful large language model around. So you can think about Palm 2, which was presented by Google in May, probably partially as a sort of response to ChatGPT. And of course, there are other models around, and I will talk about some of them today. So what is so special about them, and why, and what is language modeling in general? So who owns them, right? So what are language models? Who are the owners of the language models which are there in the wild? Yes, and what should we know about them? So some parts of my talk will be dedicated to technical stuff, and I will try to keep it short, partially because I have already talked about it in other venues, partially because, well, if you really want to know the details of how large language models work from the technical point of view, you should enroll to our in 5550 course at the master level in the Department of Informatics. Right. So, but still, like the necessary explanation slide about what language modeling is from the purely sort of technical point of view. So language modeling is essentially two tasks. The first task is to estimate the probabilities of natural language sequences. So for example, we want a system which can tell us what is the probability of seeing a sequence a lazy dog in some random English text. Or what is the probability of seeing a sequence the quick brown fox jumps over the lazy dog? Or what is the probability of seeing a sequence green colorless ideas sleep furiously? All of these sequences are probable. They are normal grammatical English sequences. But of course, the probability of actually encountering them is different, right? And we as humans understand this perfectly. But we can also formulate the task of language modeling slightly differently by saying that it's the task of estimating the probability of some word X to follow some word sequence S of some length, say of the length of 5 words. So essentially, it's the task of estimating what is the probability of seeing the word jumps after the sequence the quick brown fox, right? So the probability is, say, 90% or 50%. In fact, these two tasks are closely related. You can even say that these two are the same task because they can be reformulated so that one stems from another. So essentially, the probability of the whole sequence is just the product of the probabilities of individual words. Right? So any system which is able to tell us what is the probability of seeing the sequence the quick brown fox jumped over something, or a system which can tell us what is the probability of seeing the word jumps, or something like that, any such a system is called a language model, including our brains, which also can do the task of language modeling. But when we're talking about language models on our machines, on our computers, this task is always data-driven. So it's defined only on some collection of texts. So we train our language models on some collection of texts. Without a collection of text, which we usually call a corpus, you cannot talk about a language model. So any language model is trained on some collection of texts, and this collection of texts is inherently limited. You cannot collect all sentences from some language, right? It's impossible because the nature of any language, including Norwegian or English or whatever, is such that it can generate an infinite number of sentences, of sequences. That's why we will never see some sort of perfect language model, because in order to be perfect, it should be trained on all possible sequences in some language, and it's impossible to collect such a corpus. Okay, but what is even more important for modern language model is that any language model is also a text generator by definition. So if you have a system which can predict the probabilities of the next word after some previous word, then you can easily generate text with such a system. This is called autoregressive generation or causal generation, and it's very simple. So essentially, you have some prompt, some sentence, some words, for example, a quick brown fox. You feed it into a language model, and you ask the language model, what is the probability distribution over the words which should follow this sequence? And it tells you, okay, so the probability of the word jumps is 80%, the probability of some other word is 60%, is 20%, etc., etc., etc. And then you just pick the most probable word from this distribution. Or maybe you use some form of sampling. You just sample some word according to their probabilities. And you feed this word together with the previous words back to the language model. And then you just repeat this process until you're tired, right? Or ad infinitum. So you're generating text, right? This is, in fact, what ChatGPT or GPT-4 or any other generative language models essentially do. That's why they're called generative language models, because this is how they work. They essentially just, when you ask ChatGPT anything, it just generates the answer word by word. Well, at least on a high level. Of course, there are many technical details which will complicate this picture, but the overall process is still the same. But of course, text generation is not the only task that language models can do. And in fact, in the real world, I would not even say that text generation is the main task of the language models. Okay, but first, some history. So what changed since good old times, since the emergence of more or less modern language models, and why they are so powerful today? So why 20 years ago we didn't think that computational linguistics and natural language processing will be so popular and widespread? The man on the slide is Yoshua Bengio. So he's one of the authors of the 2003 paper where they suggested to use artificial neural networks for language modeling. Before that, people, of course, trained language models, but they didn't use artificial neural networks, or at least they didn't use it as a mainstream technique. But yes, in 2003, they suggested to get to artificial neural networks. They got very good results. Their neural language models outperformed the models which were state-of-the-art back then. And since that times, and researchers in natural language processing started to test different sort of ways how we can improve neural language models. So since then, three things, I think, have changed most. The first thing is that we now have increased compute. So the hardware industry was not stable. It developed very rapidly. And the training of the model by Bengio in 2003 took like 6 months on a very small training collection by modern standards. I guess today we would train such a model in a matter of minutes. Because, yes, we now have the so-called graphic processing units, as you, of course, know. We have tensor processing units, so all sorts of hardware accelerators which excel in matrix multiplication and parallelized matrix multiplication. And any artificial neural networks is essentially just a cascade of matrix multiplication. But, of course, everything comes at a price. And GPUs and TPUs are not distributed freely on the streets, unfortunately. That's why we have this thing which some call compute divide. So not everyone in the world can afford to just burn, for example, 100,000 GPU hours to train a relatively mid-sized GPT-like language model. So, and this number, 100K GPU hours, is not just taken from nowhere. It's really like the optimal sort of time to train a GPT-like model of 10 billion parameters on a mid-sized language. And mid-sized language means like, okay, a language where we have about 10, 20, 30 billion running words of training texts. I will talk more about it later, but still, it's not a big model by today's standard. And still you need 100K GPU hours, which is of course not something that you can do on your laptop, even if you have several GPUs on your laptop for some reason. And here what I think is very timely to say today is that publicly funded science is very important. So we here in Norway are very lucky in this respect because, well, for many reasons, but one of the reasons is that we have access to LLaMa. LLaMa is the third most powerful supercomputer in the world and the first most powerful supercomputer in Europe. So it has about 20,000 GPUs in total, and Norway owns a share of LLaMa, which makes it much easier for us as researchers to get access to these immense compute capabilities, right? And well, we in Language Technology Group, of course, among other researchers in Norway, we are already using LLaMa to train open language models for Norwegian, for English, maybe also for some other languages. So yeah, it's really important that we are so lucky, but yeah, it's still a problem. The compute divide is still a problem because not every country is as lucky as Norway is. The second thing that has changed since good old times is increased data. So the model by Banjo was trained on a corpus of a very small size. Nowadays, language models are trained on like immense amounts of data, and the only source of textual data of this in such numbers is the internet. So we have to crawl the internet to get these billions and trillions of words of running text. And of course, most of it is in English. And I will talk more about it later, about this language divide, right? So yeah, this is just the sizes of the training corpora for some of the popular language models of recent times. So you see how it increased from like 3 billion words in 2018. So it was the amount of words that BERT was trained on. And now in 2022, we have this chinchilla model, which was trained on 1.5 trillion words, et cetera, et cetera. And human children are good to go with less than 100 million words, which tells you something about how far we are from something resembling general artificial intelligence. A natural question is, what is the size of the corpus that ChatGPT is trained on? And we don't know. At least OpenAI didn't disclose the details of that. So, but still, it definitely was an immense amount of texts and code as well. And as I've said, not all languages are created equal in terms of available data. So yeah, different languages have different sizes of the corpora that it is technically possible to get. And I will talk more about it later. Right, and the third thing which changed since good old times of Banjo 2003 is new and better architectures of artificial neural networks. And I will not spend time on describing what are the advantages of the so-called transformer architecture, because probably you're bored to death with explanations of what transformer is, and you can easily find it on Wikipedia or whatever. But yeah, so the takeaway message here is that almost all the language models that you hear about today are using the transformer architecture, and it really allows the creators of the models to use the existing data and the existing compute in the most optimal way. So you really can like use all the power of all these crazy expensive GPUs and TPUs and all all these corpora of the size in trillions of words. Yeah, but still, it's important to still understand that even the most complicated transformers are still just, well, they are trained on the task of language modeling, of predicting the next word, even if they are very powerful artificial neural networks, etc. But still, we just train them to predict what the next word will be. Right, and by the way, we're not limited to predicting, to just imitating the human processing of the text, so the left to right processing. We do not have to actually train the model to predict what will be the next word given the 5 words to the left. We can actually use what is called masked language modeling, when we just take a sentence, mask some word in the middle of the sentence, and then ask the model, what is this masked, this omitted word, right? And yeah, so this is our Norbert Free model trying to guess what is the omitted word in this ja, vi, then mask that landed, right? So what it tries to guess what should be the word behind the mask. And yeah, as you can see, it correctly guesses that it will be Esker, right? With the probability of 46%. Yeah, and the next most probable word is E, then har, then liker, etc., etc., etc. So yeah, and this is again a very simple and small model by today's standard, right? So this is essentially how the masked language models are trained, right? So we just feed millions and billions of sequences like this and push the model weights so that it correctly answers the question what word is behind the mask. And yeah, you can, by the way, download this model and use it for whatever purposes you want. Right. So yeah, modern large language models. This is a genealogical tree of large language models that we have since 2018 up to now, more or less. And I will show this slide once again in a few minutes. But what is important is that we have this constant stream of so-called foundation language models. So the term itself is a bit ambiguous and disputable, but still, like, the thing is that since it takes so much time and resources to train a really large language models, nowadays the paradigm is usually that someone who has the resources trains a very large language model on very large text collections, and then makes this model public in this way or another, either by just making it available for downloading, or maybe via web interfaces or API, like ChatGPT, for example, right? And then others, the researchers, the practitioners and users, just use this model to solve their tasks. Maybe slightly adapting it in the process called fine-tuning, but still the thing is that usually you do not train your own BERT or your own T5 or your own large GPT model from scratch. At least, it's not expected from you, right? Yes, so this is just some. These are just some names of the most probably seminal models which people who are dealing with large language models should know: BERT, GPT-3, T5, Palm, then ChatGPT and GPT-4, and then we have LLaMa. And an important thing is that you can see that although in the beginning it was almost obligatory to publish a paper on a scientific paper on your language model, right, in a peer-reviewed venue, as was the case with BERT, GPT-3, T5, etc. But then, for example, ChatGPT or GPT-4, they are described only in a technical report, which look, well, on the surface, it looks like it is a scientific paper, but in fact, in its content, it's more like a commercial, right? So it essentially doesn't give you any details. It just tells you how great ChatGPT or GPT-4 is. And it is not peer-reviewed, of course. Yeah, and then, for example, LLaMa, which is a comparatively open language model by Meta, by Facebook, right? It's described in in a scientific paper, which is not peer-reviewed, but just published as a preprint on arXiv, right? So there is some sort of a degradation here. Like there is more and more a tendency, like not to undergo a proper peer review in the description of your large language models, which is bad and which should be stopped, I think. But still, just a quick overview of 3 types of modern language models, which again is important to understand before we get to like ChatGPT, etc. So there are 3 major architectures, and they are encoder language models, decoder language models, and encoder-decoder language models. Encoder language models are models like BERT. So these are models which essentially are trained to produce representations of input words. So they encode the input text and produce things which are called embeddings or some useful representations of these words. Right? They're also known as masked language models. And they are probably not as much hyped nowadays as decoder language models like GPT. But in fact, in real-world tasks like text classification, for example, etc., you will still see them very widely used. Then the most famous, probably, type of neural language model architecture is decoder language models like ChatGPT or GPT-3. So they essentially, they are trained to just predict the next word based on the previous words. They are decoding the current model state into human language words, right? So they are specifically trained to generate text. As I've said, in fact, all language models can be used to generate text, but decoder language models are sort of more adapted to do that. And ironically, it's the most classical type of language models, dating back to like 70 years ago to Claude Shannon, etc. So this is like the first type of language models that humans actually started to think about after the Second World War. But nowadays, they once again became like the most popular. And finally, the third architecture is encoder-decoder language models, which are trained both on encoding and decoding. So they just cast all the natural language processing tasks as transforming one text into another, right? So the model has some sequence, some word sequence as its input, and some word sequence as its output. It's quite convenient because you essentially just whatever you want to do, you convert it to this text-to-text format. Of course, you can think about machine translation. Machine translation is like the most natural application for encoder-decoder models. But in fact, all other language tasks can be cast to this format. And then the most popular example of an encoder-decoder language model is T5, and hundreds or thousands of models which are produced from T5 in this or that way, including Norwegian T5. So we have dozens of Norwegian T5 models nowadays by different labs. Right. The next very important thing which helps modern language models is the so-called instruction fine-tuning. So if you have a generative language model which can generate text, you can additionally fine-tune it on some set of instructions, which can be, for example, summarization instructions. So you specifically fine-tune the model on summarizing some texts, or on some other tasks. And the idea is that if you fine-tune a large generative language model on some set of these instructions, then it was shown that it generalizes on unseen tasks. So it seems that the model sort of learns how to execute instructions in general. So even if some tasks were not among this original data set of instructions, still the models can somewhat execute these instructions. Of course, for this, you need manually annotated data sets. So you need humans who will actually create these instructions, right? But still, it's something that most modern language models are using. Yeah, and then the necessary slide about ChatGPT. Well, what we know about ChatGPT is that it is a successor of a model called GPT 3.5, which was published by the same OpenAI lab in 2020. And GPT 3.5 is a decoder language model, an autoregressive language model. It has 175 billion parameters, which is quite a lot, but not, in fact, it's not like the largest language model in the world. So in this plot, you can see that there are some language models which are much larger, in fact. So we do not know exactly what size the ChatGPT is, but most probably it's the same size as GPT 3.5. So most probably it's also 175 billion parameters. And usually, yes, the larger is the model, the better is the model, with some exceptions, of course, but still, usually it's the case. We do not know also what was the size of the corpus that ChatGPT was trained on, most probably something about 200 or 300 billion running words. And yeah, but what we know is that ChatGPT, as well as other decoder language models, excel in generation. So you can ask it, yeah, like in this case, I'm asking this model which is available through the interface at gpt.uio.no, which you probably know, where we assume that like when we use ChatGPT through this interface, that the data never leaves, well, Europe or UIO or probably Europe, yes. So it's like, yeah, of course we still have to trust someone, probably we have to trust many actors in this case, but still it's probably more, like it's probably safer than using the general ChatGPT web interface. But anyway, so what I want to show on this slide is that, yes, you can ask quite a difficult question and get an answer which is, well, which makes a lot of sense, right? So the model really tells you that, yeah, it doesn't know who teaches the In5550 course at the University of Oslo. Go to the website. That's the best I can do. And yeah, of course, it's natural because we know that ChatGPT was trained only on the texts up until 2021. So yeah, it doesn't have most up-to-date knowledge. And that's impressive because if we ask the same question to the encoder-decoder FLAN-T5 model, it can only hallucinate in the response. So it can only tell you that, yeah, John Lennon teaches in 5550 course or something like that. So yeah, that's impressive. And this is, of course, part of the reason why people are so much fascinated by ChatGPT and the like. Yeah, but the important addition and the important thing which made ChatGPT and some other models so successful is large-scale human supervision, which was used in the process of training them. It is also known as the abbreviation RLHF, which means reinforcement learning with human feedback. And it's really important. And it's, we're lucky that it is at least described in a scientific paper, which describes the so-called InstructGPT model in 2022. So the idea is that, okay, you have trained the large language model, then you do the usual instruction fine-tuning on some data set of instructions, but then you additionally refine this model on human preferences. So you essentially just ask the model to generate responses to some set of prompts, and then you ask humans to rank these responses by like what response is better, what response is more helpful, more harmless, more honest, more factually true, etc., etc. And then you train a separate model, a separate reinforcement learning model, which sort of will be used then will be used later to decide how to respond to human questions. And yeah, so ChatGPT at least was definitely refined in this way on hundreds of thousands of interactions with humans, including interactions with some of the users of ChatGPT web interface, probably some of your interactions as well. We also know that it used paid workers for this, and they were paid like $2 per hour, like workers from Kenya. So there are like some quite shameful stories, I'd say. But still, we know that, at least from the technical point of view, this reinforcement learning with human feedback does push the models towards being more helpful, more harmless, and more honest. In fact, it's interesting that in principle, depending on the guidelines that you give to your human annotators, you can push the models towards being something else, right? You can push the models towards being more harmful or less honest, etc., etc., etc. So yeah, this large-scale human supervision is so important that, in fact, nowadays some researchers even suggest to call such language models instruction-tuned text generators, because like this term sort of covers two most important things about these models: that they are instruction-tuned and human-supervised, and that they generate text. But it's still like, I don't think there is a consensus in the scientific community about that, so I will still continue to call them decoder language models, maybe with some human supervision. Right, so a great image from a great paper by Kachon et al. 2023, which shows like how we evolved from 2017 to 2023, yeah, how we get from the invention of the transformer architecture to generative pre-training, to multitask training, then to this reinforcement learning from human feedback, etc., etc., etc. Yeah, and another important thing is that although ChatGPT itself is not that much scientifically novel, but what is really great about ChatGPT is how OpenAI, with some financial help from Microsoft and others, managed to organize the large-scale regular inference. So the fact that ChatGPT answers millions, or I don't know, maybe billions of questions every day, it's really expensive, and it's really a great engineering effort. So from this point of view, I really adore OpenAI efforts. But yeah, a good question is how good ChatGPT is in comparison to other models that we have now. So we have some state-of-the-art systems in NLP. So is it true that we don't need any other models, and we should just use ChatGPT, pay some money to OpenAI, so that it will allow us to use its great model to solve all our tasks? So no, ChatGPT is not a superior language model. It's far from that, but it's not bad. So in fact, there are some publications which tried to evaluate ChatGPT, to compare it to other models. And I will not go into details, but the thing is that, well, ChatGPT is a jack of all trades and master of none. So it's more or less good in all the tasks, but in any task you can find a model which is much better than ChatGPT. So this plot on the right is the ChatGPT performance loss in different tasks compared to state-of-the-art. So in all the tasks, it is worse than the state-of-the-art systems, but in some tasks, it's not that much worse. So yeah, it still, of course, can be used. An important question is how important to the performance of ChatGPT and such models is this reinforcement learning with human feedback. And there are some papers which claim that, in fact, it's not important at all, and in fact, the generative language models already know everything. You do not even need this reinforcement learning with human feedback. You just have to get the right prompts, so to ask the right questions. This is called superficial alignment hypothesis, that you don't need any alignment. But it's not clear whether this hypothesis is true. And for now, most probably this reinforcement learning with human feedback is really useful, and without it, well, large language models probably will be much worse. Also, we don't know how large ChatGPT is, and that's another reason why it's difficult to meaningfully compare it to other models, about which we at least know how large they are. And of course, it's not trivial to properly evaluate ChatGPT because the model isn't actually available, right? You cannot download the model. And this gets us to the most important thing: who owns these models, right? So again, this genealogical tree of large language models shows you which of them are open and which of them are closed. So the empty rectangles are closed models, and the colored are open models. So you can see that some models, really, you can download them and use them if you have the necessary hardware, of course. But more and more models are closed, and this is bad. So, for example, GPT-3 and ChatGPT are closed. They're not publicly available. You cannot download the weights. You can only use the models via API, web interfaces, or whatever. And of course, it's not how things were used to be in NLP and in computer science in general. So usually the typical workflow was that, yes, you download a language model pre-trained on some large collections of text, then you fine-tune it on some of your data, and then you use it, right? So for example, we have all of this set of Norwegian data sets on which you can fine-tune your model and then use it to deal with Norwegian natural language understanding tasks. But yes, you cannot do this with ChatGPT, or you cannot do this with Bard by Google. You cannot do it with Claude by Anthropic, etc., etc. You cannot easily study these models. You have very limited parameter control, so you cannot run complex experiments with these models. These models are changing sometimes daily in very opaque ways. So the ChatGPT yesterday might not be the same model that you're using today, right? The instruction and human preference data sets are also not publicly available, or have very limited public availability. And this is a major disadvantage, both from scientific point of view and from practical point of view. By the way, if you want to to learn more about why it's really a large scientific disadvantage that ChatGPT is not available, you should read this great blog post by Anna Rogers, which is called "Closed AI Models Make Bad Baselines." So the link is on the slides. I guess the slides will be available after this talk. So yes, but in fact, another world is possible. So it's not like all the models should be closed and proprietary. We know that the training code can be fully available to the public. That's relatively easy. Almost everything is available now. The models themselves can be fully available to the public. So, and we have some great examples starting from, so we have T5 models, but we have also the large generative decoder language models like Bloom, Opt, LLaMa, some Norwegian language models by the University of Oslo and by National Library AI Lab. These models are open. You can download them. You can do whatever you want with them. The training data sets also can be fully available to the public. So for example, the roots corpus on which the Bloom model was trained is fully available. You can study it, you can download it, etc. The instruction and human preference data sets also can be available to the public. And now we can see that more and more open source data sets like this start to appear, like Dolly, Open Assistant, and many more. So it's possible, and we really hope that there will be much more. And Language Technology Group at the University of Oslo participates in a very large European Union-funded project called High Performance Language Technologies, HPLT, which aims to provide open language models and data sets for all major European languages, and not only European, in fact. So yeah, there are some promising initiatives which I hope will break this tendency. But yeah, a good question is why models should be open. So why is it so important? So first of all, large language models are integrated in our lives more and more, and so society cannot just rely on black boxes provided and controlled by big tech companies or states. And well, sometimes it's difficult to judge who is worse, right, and who is more threat. So large language models are critical technology, and I believe that critical technology should be transparent, should be reproducible, and should be under quality control, right? And it's possible only when the model weights are public, when you can download and critically study them. And it's not even talking about science. Of course, for science, everything should be open. But even for society in general, such artifacts of critical technology should be open and publicly available. And the same applies to training data, so the training corpora. Importantly, proprietary systems, closed systems are usually, not always, but usually they're made for profit. And this means that their creators are sort of incentivized to overhype the achievements of these systems, right? If you train your model to get money for it, then of course you have the incentives to like make it sound as if it is better than it really is. So this also should be kept in mind. There are also practical risks and harms, right? So with models like ChatGPT and others, there is the threat of vendor lock-in when you are accustomed to using a model by one vendor and then you're locked into it, right? And yes, this also happened when you buy API access from OpenAI, like the University of Oslo did, for example. So vendor lock-in is not good, and we know about it since times unknown, and it applies to large language models to a very big extent. Lack of reliability, so you never know when OpenAI decides to, for example, change the model in a substantial way or remove the access to this model. So of course a company can promise that they will always provide access to this particular model, etc., but it cannot compare to actually having the model weights on your hard drive, right? So the choice is obvious, I think. But some people ask, so what about security, right? We cannot allow bad guys to download our models because they will do bad things with our models. They will analyze them and find out how to use them to build a bomb or do something else very bad. So good guys should control the access. To this, there are many answers to these claims, but I will limit myself to one very obvious answer, I think. Security through obscurity doesn't work. And I guess cryptographers know this, again, since times unknown. And this can be proven by one simple example. So again, this question to ChatGPT, who teaches in 5550 course at the University of Oslo. ChatGPT tries to be careful, and it just, as we have already seen, it replies that, I don't know, sorry, just go to the website, I don't know. We see obvious traces of human supervision here, maybe even some hard-coded rules, we don't know for sure. But in fact, it's not bulletproof, and even though the model itself is not available, people on the internet were quite successful in doing stuff with clever prompt engineering, and then just asking the model the same question, but in a different formulation. And then ChatGPT, even this ChatGPT available through the University of Oslo web interface, just tells you that, yeah, the teacher for the in5550 course is Professor John Doe. And of course, this is a very harmful example, right? It's just a toy breach. But you can imagine that with enough fantasy and creativity, you can do all sorts of interesting things with large language models. So obscurity and the fact that you cannot download the weights does not prevent bad guys from doing bad things, unfortunately. Right, so yes, we need open models, and of course it's important that different levels and different degrees of openness are possible. I really recommend this great paper by Liesenfeld et al., and they have this table which is updated real time in this opening up chatgpt.github.io. So they keep tabs of like what models are open to what degrees. So the green rectangles are like fully open, red means not open at all, right? So Bloom by Big Science Workshop is by all means the most open large language model now. But even it is not like fully open. It lacks some important things. So yeah, but yeah, a very different degree of openness are available. So ChatGPT is at the bottom of this table, of course. Nothing is open about ChatGPT, or almost nothing, right? Yes, and getting close to the end of my talk, just one last point to say. We know that large language models are becoming better when they become larger. This is called the scaling laws. So we know that when you scale a language model, you train it for like more time, more steps, you use more parameters, etc. You have these emergent properties, so language models become more and more powerful. All of a sudden, they start to be able to do arithmetic operations or decide like which words in context are similar, etc., etc. It's fascinating, of course, and we will see many interesting applications of language models as smart assistants, etc. But will it continue forever? So until we just get to general AI? Hardly. It won't, for several reasons. There are some natural limits to further development of language models, as I believe. So first of all, for most languages, the total size of unsupervised training data is limited. Humans, unfortunately or fortunately, do not just generate texts ad infinitum. So we have some limited amount of texts generated by humans. And of course, at some point, we will face the problem that a large amount of text on the internet will be generated automatically. This is something which is called data poisoning. And for now, it's not yet that important, but I guess in a few years, it will become a real problem, right? Then, yeah, as I've said, for many languages, the size of the text collections that we can get hold on is very unequal. So these are just the sizes of the training corpora that we get from the web within the HPLT, the HPLT project. So for English, we can download from the web about 10 trillion words. It's a lot. For Chinese, it's about 2 trillion words. Same for Russian. For German, it's already less than 1 trillion. And then we have less and less and less and less and less until for Norwegian we have about 55 billion words. You should mind that it's deduplicated, that it is the texts before the duplication. So some of them are actually copies of each other, right? After the duplication, for Norwegian, we have only about 30 or 40 billion running words. And yeah, of course, there are languages which are much less lucky than Norwegian, which are smaller, right? So yeah, for the majority of languages, we cannot train in the regime of infinite data like people did for English, and that's a problem. It's still like 30, 40 billion running words is still enough to train a decent language model for Norwegian. Or, of course, you can also train on a multilingual collection like the Swedish initiative GPT SW3 is doing. Or you can fine-tune an English language model on Norwegian data like the National Library does, for example. Or another promising way to get some more data is speech-to-text technologies. So some texts are sort of imprisoned in audio recordings, and it would be great to convert them to written texts. And the last limit to further development of language model is that human supervision resource is limited. So we need tens of thousands prompts for instruction fine-tuning. We need hundreds of thousands human preferences for RLHF. And well, human labor is expensive, and it's becoming more and more expensive. And yeah, we don't want to train on prompts or human preferences which are machine translated from English, for example, or synthetically generated. We need real human annotation, and it's expensive. So this is a bottleneck, right? So yeah, this is just a summing up slide. I believe the most important thing from here is that we are now at a bifurcation point, at the point of choice, where we as a society will have to choose between closed proprietary models, which are owned by business or states, and open and transparent models, which are owned by society as a whole. So the question is what we will choose. I guess that's it. Sorry for taking a bit more time.
Thank you. Thank you very much for this very interesting and very good overview and talk us through the language models as of today. And we open for questions from the audience. I have many questions, Andrew, but I can, while waiting for someone out there, as I understand, okay, I can speak very highly, and if you can repeat. I'm using ChatGPT, and but I think I use it as a language machinery. But it tends to come up with content that it seems okay, but might not be correct. So how do I go forward to really use it as a language machinery, not being, but having control of the content? What are your thoughts about that? I try to think of it myself. What are your thoughts about these types of questions?
Yeah, so essentially you are talking about how can we learn to trust what generative language models tell us, and how can we tell whether their answers are factually correct, right? So yeah, there is like a large field within NLP of disentangling the language skills and the factual correctness, right? So how can we sort of concentrate some efforts on making sure that the models generate natural language, correct grammatical sentences, and other efforts can be focused on making sure that the models have some trustable sources to get facts from, right? So there is this large field of retrieval augmented language models, which, some of our PhD students present here can really tell you more about this. But yeah, I think this is really promising, and I think that in the future we will see more models which rely on some trusted sources, trusted knowledge databases, like Wikipedia, for example, maybe something else. But yeah, for now, of course, you should just be critical towards anything ChatGPT or any other language model tells you.
Thank you for that answer. We have a question there.
Hi, thank you for your talk. There's one more angle to this ownership discussion, I think, and that's this training data, also why it's not so publicly available. A lot of it is, well, stolen. There's a Dutch newspaper, a prominent one, that discovered that their paywalled articles were one of the main sources for training data for the Dutch part of GPT-3. So how do you feel that factors into this possibility of going forward with open models if the most successful ones now rely on stolen data?
Yeah, so the fact that a very large part of written texts in the world is copyrighted to this or that degree, it can be a topic of probably another talk. And it's extremely important, of course, to all these discussions about large language models and training data. So we have some amount of text which is clearly licensed with open licenses, but unfortunately, most of the texts on the web are not. And the question of, well, whether you can still use this text to train a language model which then will be used for commercial purposes, I guess we don't know, right? So I guess we as a society will have to develop some new legal terms for this. And you probably also heard about these legal issues with the Internet Archive in the United States, like where the owners of some copyrighted materials sue Internet Archive for providing access as a library, right? So I think we will face lots of issues with that, but probably legal people will be more equipped to answer these questions than me.
Thanks, Dan. We have a question down there.
Yes, thank you for a great talk. You leave it open for society to choose, but what do you say is the responsibility of researchers and engineers in the private sector regarding their, let's say, involvement in informing and maybe even nudging the debate and the decision that society takes? Because the natural parallel one would make is like the case of nuclear weapons, where there was a lot of let's say, activism on behalf of the university professors and engineers in the private sector. Do you perceive something similar happening here for large language models?
Well, it is happening. Some of you might probably heard about this quite recent open letter to prohibit further research or training of large language models, which was signed by some academic celebrities and industrial celebrities, I'd say. Well, I'd say this discussion still continues. Let's put it like this. I personally do not believe that we will soon see large language models eradicating humanity to optimize their loss. I don't think so. But yes, this discussion is still continuing, and yes, some people think that large language models are somewhat equivalent to nuclear weapons, right? That you should control them, you should, introduce lots of regulations. I'm not sure about that for many reasons, which probably we do not have time to discuss. But yeah, it's definitely, these topics are definitely something that we should talk about, and yeah, this is an ongoing discussion in the society and in the academy as well.
Thank you. I'm one of the person that actually signed, and not to stop the development, to say that, okay, let's take a pause, let's think a little bit more closely about what happens. There is another question down there, yeah.
Hi, thanks for the talk. I have a couple of questions. The first is more for a course maybe. How do these models go from predicting the next word, what is the most probable word, to giving simplified summaries of specialized topics? That's my first question. The second question is, how do you define these running words that you mentioned on one of the slides and when you gave these numbers? Maybe the most provocative question is, I totally agree with you on this open sourcing of these language models, but I personally do not have a good answer on how to prevent misuse of them. Do you have any thoughts on that?
Sorry, how to prevent what?
Misuse.
Ah, okay.
Yes.
Well, I don't have an answer to how to prevent misuse of large language models. I don't think there is any way to prevent their misuse at all. As we have seen, even the fact that ChatGPT is not available doesn't prevent people from misusing them. And there is some research which shows that most probably ChatGPT and subsequent models by OpenAI are already poisoned by, by prompts which were specifically designed to change the model by some groups like spammers, etc. We do not know for sure, and we cannot even analyze the model, right? So I'd say, in the same way as we can't prevent misuse of the knowledge which comes from school books, right? A school book in chemistry can teach you how to make a bomb, in principle. In the same way, well, large language models also can be used to teach someone to do bad things. And I'm not sure there is any way to prevent it.
Okay, thank you. It's 1 o'clock, so we have to stop.
Yeah.
Sorry for that.
But
This
I'll
is
be
very
here, so
interesting.
yes, if you are
so you
interested.
can talk to Andrew afterwards. I would like to say that, of course, there are one of the reasons, one of the things we do to prevent things is, of course, that there will come regulations around AI in general. We don't know really what that's going to be because it's up in the air and there are proposals all around. But let's face it, everything can be used for or misused or used for bad purposes. So there has to do with our attitude and ethics and all these types of questions. But thank you very much, Andrew. Thank you very much for a very nice talk, and thank you very much for coming. There are much more that's going to happen here during fall. We are having Data Science Day, and that is Data Science Day for the good. That's the topic. We're also having talks here on uncertainty and limitations of generative methods, and also on how AI can be used to understand climate change. So, but today it was large language model, and so far the most popular topic that we have had here at the Science Library. So thank you again, and give Andrew a big hand.
Thank you all.